Assalamualaikum and very good day to our lecturer, Dr. Muhammad Zulkarnain for Bmmh 2503 Fundamental of Hvac and Refrigeration. So we will present about case study small office Hvac system. This is our members HARISHWAR, MOHAN, HAKIM, Smail and MUHSIN AMILI. Introduction. The air conditioning system is something familiar nowadays. The demand is getting higher day by day. Based on Malaysia's energy information in 2020, Malaysia consumed 31% coal to supply the electricity to the consumer. Based on Malaysia's energy information in 2020, Malaysia consumed 31% coal to supply the electricity to the consumer. It is about 19,000 kTOE in the year 2020. According to Malaysia Meteorological Department, the minimum temperature range is between 23 and 27 degrees Celsius. Meanwhile, the maximum temperature range is between 30 and 34 degrees Celsius. At the same time, a suitable system must be applied to make energy consumption efficient and reliable. Malaysia, which is located exactly at the equator, gives the tropical season, which Malaysia experiences high humidity and sunny day for 365 days a year. Every component in the Hvac system have its purpose, such as compressor, condenser, expansion valve and evaporator or cooler, but air conditioning has been built in variation with various sizes to provide the required cooling capacity in the spaces. Every component in the Hvac system have its purpose, such as compressor, condenser, expansion valve and evaporator or cooler, but air conditioning has been built in various types with various sizes to provide the required cooling capacity in the spaces. Ventilation is one of the important aspects when it comes to the comfort zone. According to P. Nelson 2007, fresh air is required to remove heat and particles that are emitted in the building, and it is important that the fresh air flow through all the occupied spaces so that every part of the space experiences a sufficient amount of fresh air. So the method for this case study is to identify the location of the office and the sun's direction, which is located in Ayekro, Melaka at 20 meter elevation. The system used in the office is an air-cooled chiller with ducting system, and it has been controlled by air handling unit. The operating time for this office area is 8 AM to 5 PM and 5 days a week. The total area is approximately 4 square and 50 meter square and installed with multiple ceiling diffusers to ensure the air distribution in the particular area is distributed well. The prediction of the fresh air supply is equal to the supply of air for the ventilation, also to study the indoor air quality and energy consumption in the particular area. So that's all from me. Thank you.
A very good day, sir. My name is HARISHWAR MOHAN from Bmmh S1/2. So my metric card number will be B0920103668. So here's our data for air conditioning unit. This is the room size and also unit per room. So from room number 1 to 6, the dimension will be 6 by 6, and room number 25 and 26 will be 5 by 5. Room number 7 to 24, then 27 to 48 will be 4 by 4. So there's our area, the total area. Then here's some data for air change rate per hour by ASHRAE. So here's the recommendations by ASHRAE. So for homes 1 to 2, for hotel rooms 1 to 2 also, for offices 2 to 3, for retail shops 2 to 3, then for schools 5 to 6, for sport facilities 4 to 8, and also restaurants 6 to 8, and shopping centers 6 to 10. So here's the air change rate per hour by ASHRAE. So this is the data which with the drawing system used for the small office. So here's the system used for small office. So cooling load capacity in the office. So we using the Daikin heat calculator. Then for room number 1 to 6 with full glass window north. So the BTU H per hour will be, the cooling capacity will be 7,940. So the total for 1 to 6, the 6 rooms will be 47,640. 25 and 26 will be 3,625. That's the total. Then 7 to 11 fully glass window, 4,640. Then room number 12 to 24, then 27 to 48 will be 3,040. So for the total, for the grand total will be 184,490. Then here's our data. This graph compares actual week HVAC energy consumption and also predicted weekly HVAC energy consumption. So the actual weekly HVAC energy consumption is more greater than predicted weekly HVAC energy consumption. The energy consumption also includes an HVAC system, light and electrical equipment such as computers in the office as predicted consumption. That's all from me, sir. Thank you.
Assalamualaikum and hi, my name is HAZRIQ bin JULAILI, and today I want to tell you about the data for our location for the case study on this HVAC system. Alright, first of all, the type of building is the small office. The location is 21641 North, 1021631 East in Ayer Kerom, Melaka for the latitude and longitude. The area of the study case is 40 times with 50 meters square. The type of wall is a concrete wall. The window location is north and west. The type of roofing is a concrete slab. The cooling capacity as we calculate is 15.7 ton refrigerant, 15.37 ton refrigerant. The population estimated is 110%, and the HVAC operating time is 8 hours. Similar to the office hours. Alright, so the result. So as you can see, the result shown is energy consumption versus time. Alright, so as the result, the highest energy consumption in the building reached its peaks at 1 PM for more than 50 kilowatt per hour. This may be the factor of inside the building activities, the number of occupants inside the building, and the heat generated from the electrical equipment such as computers or server rooms. Next is the result for the parameter for the AHU on the office building floor. So from the data on the table 5.0 gain, air handling unit on the office floor, however, the water pump, light and electrical equipment need to be considered because all these equipment also consume high energy consumption other than air conditioning. As you can see, the parameter for the AHU for the temperature of written air is 23.7, mixed air is 24.2, and supply air is 20.0. So the humidity as recorded is 70.6, 74.1, and 84.4. The flow rate for written air is 5.59, mixed air 5.45, and supply air is 5.87. So the supply voltage at the distribution board is 408 or 408 volt. Current is running at 70.7, power in kilowatt 9.38, and the power factor around 0.75. Right, ventilations result for the air change per hour. So as you can see, the air change rate need to be sufficient to prevent air contamination inside the building, otherwise it could harm the occupant inside the building. Approximate 110 occupant in the building, and the height is, the ceiling is approximate around 3.5 meter. 20 cfm is good enough for the air change rate to ensure the level of the air change rate is equal to all areas of the office building based on the HAZRIQ tables.
Hello, my name is Smail and I'm from Bmmh section 1-2, and today I will discuss about the discussion for our assignment of the Bmmh 2502. And as you can see from this slide, our discussion is after all the data we collected analysis we conduct in this case study, we found an ideal chiller system for this office. You see from this picture, The recommended system that is suggested for this office are air-cooled chiller system. Because we're choosing for this type because its cooling capacity are 5.85 kilowatts and the compressor type using scroll compressor 1.5 kilowatt. Because this chiller can support a huge building such as our case study. There is office and our chosen office are FTKV second floor office that you can find the blueprint from the other presenter. Now we will discuss about its specs first. For this system, it using R32, R40, R47, and R410A. And it for its power supply are 3 phase 50 Hz that equal to 380 watts. And for the water flow of the chiller, it's 10.8 meter cube per hour. And the cooler type this system used are built in with a copper coil. And for the condenser use a thin copper tube. For the recycle. Then our finding of air chiller system for the office building. An industrial air-cooled system is a refrigerant system that cools fluid and work in tandem with a facility air handler. A chiller has 4 main parts. That is a evaporator, compressor, condenser, and EXP, or we call expansion valve. And for the next point, the cooling capacity is 59.8 kilowatt of the chiller system is sufficient or enough to support cooling effect of the building that we study to maintain each room to reach a desired temperature, or we call comfort zone for each individual. And for the third point, the air handling unit, or we call AHU, with the ducting system help the office to filter and control the quality of the air that will reach the office space. For the fourth point, the air handling unit AHU also help to control the air temperature that regulate the air conditioning system in a cold or hot. So the thermal sensation in the office is desired by the point. And for the fifth point, air cooled chiller works by absorbing heat from the processed water. Once the water in the air handler unit is used, it will become warm and sent back to the chiller. The heat is transferred away from the water using the chiller vapor. The liquid refrigerant evaporates as it moves over the evaporator tube, creating a low pressure gas. Thus, the evaporator refrigerant travels to compressor, where the low pressure gas is compressed into high pressure gas. The gas then leaves and goes to the air-cooled condenser, while the condenser heat is removed from the chiller by being blown outside through the fan inside the cooling tower, or we can say the condenser. Okay, for the final slide, because of the heat is blown outside of the chiller, it is ideal to place the chiller outdoor or in a large indoor location that will not have the excessive heat, such as large empty room that can contain a chiller that take a place a very huge space between the chiller, because it the smaller place will affect the performance of the chiller. Okay, for the next point, after the gas leaves the condenser, the refrigerant changes into a high pressure liquid. The high pressure liquid travels to the evaporator through an expansion valve. During the process, the refrigerant changes from high liquid pressure to low pressure liquid. Because an industrial chiller works and produces cycle, this low pressure liquid is then transferred back to the evaporator, where the whole cycle repeats itself. That's for my explanation on the discussion. And we move to the next presenter, that is Mr. AMILI. That's all for me. Thank you.
Assalamualaikum to Dr. Zulkarnain. My name is Mr. AMILI bin Musli. Today I'm going to present what is air handling unit or AHU. An air handling unit, commonly called an AHU, is the composition of elements mounted in large accessible box-shaped units called modules, which house the appropriate ventilation requirement for purifying, air conditioning, or renewing the indoor air in the building or premises. So for our next discussion is, what does an AHU consist of? First is air intake. Air handling units collects air from outside, which is treated and distributed throughout the room, or indoor air that is recycled. Second is filter. Depending on the air purifier requirement, the filter applied will have a higher or lower particle, viruses, bacteria, odors, and the other air pollutant retention. Third is fan. This is an electromechanical system that powers the air to expel it from AHU to the ducts that distribute the air throughout the room. And fourth is heat exchanger, device that transfer temperature between two fluids, in this case, coolant and air separated by solid barrier. And the fifth is cooling coil. The air passing through the module is cooled. In this process, water droplets can be generated, which are collected in condensate tray thanks to the built-in droplet separator. And the sixth is silencer, coating that considerably reduces the sound level of the installation. And lastly is plenum, empty space in which the airflow is homogenized. And for our next discussion is how to reduce the energy consumption for air conditioning in the office area. First is using the optimal room temperature and maintaining it very well. The air conditioning system needs to be cleaned regularly to ensure performance does not deteriorate. And the third is using the inverter system will help energy efficiency because it runs at consistent speed after reaching the room set temperature to achieve power saving function. And lastly is temperature adjustment must not be set too low. Improper use of air conditioning will indeed increase power consumption. If not necessary, there is no for a 16 degrees temperature setting because the lower temperature of the air conditioning, the higher the power consumption. So for our conclusion of this case study is, by performing case study in particular location will improve our understanding of the air conditioning system. Second, energy consumption factors are very important to be considered in order to reduce operating costs while choosing a suitable system for the office and gain a desired thermal comfort. And lastly, the air conditioning should be maintained throughout its lifespan to prevent any problem that will affect the overall efficiency of the air conditioning system. That's all for me. Thank you and Assalamualaikum.